Hi viewers, welcome to the channel and welcome to another episode of Learning FreeCAD for Beginners, where we show the fundamentals of FreeCAD from a beginner's perspective. We're concentrating on the A2Plus workbench at the moment and we're looking at the constraints. We're going to be making a simple assembly like this with a number of constraints in there going over the circular constraints. So we're going to be using the sphere center ident constraint, the circular edge constraint, the axis constraint. And these allow us to select, say, a circle and another circle and place those on top of each other and allow for rotation rather than translation or transformation. Circle and sphere constraint, we can create rudimentary ball joints. And the axis constraints keep edges in line with the axis of that edge or even circles in line, etc. We're going to be making this very simple construction, which allows me to actually move this arm across this flywheel and see the ball joints moving. So let's have a look at this project in the A2Plus workbench.
If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel.
So I'm in the part workbench and I'm going to create a sphere in here, and also I'm going to create a cube, and we'll give that a bit more length, width and height, say 12 across all three. And we'll transform the sphere, right click, transform, and we'll place it somewhere in the middle. But I just want the top of the sphere just jutting out from the top. Something like that. So okay, that. I want to keep the cube and remove the sphere from inside. So come over to the part, come down to Boolean and come down to cut. So we've created this hollow in here. Next thing I'm going to do is create another sphere, and we'll transform that, right click, transform, and bring it over to the side, hit OK, and I'm going to also remove the top of this sphere. There's a reason for this. I'm going to create another cube and just add another boolean, right click, transform, and I'm just going to cut the top of that sphere. So what we're left with, once I transform it up, is that the sphere will have a small slice taken out the top. So, okay, highlight the sphere, control click the cube, sphere then cube, and we'll move that sphere over a bit more. Let's right click, transform, it's around about the middle. There we go. Okay, that's we want to keep the sphere. Control click the cube, and we'll use the cut from the toolbar this time. So we've got the circular hollow and the circle on top. Let's come over to the A2Plus workbench and look at the constraints that we need. So to constrain this sphere inside this hollow, if I click on the sphere and control click inside the hollow, we'll see the constraints that come up. So we've got this sphere center ident constraint. So this is places a sphere on sphere constraint. Now before I do any of this, we first got to make this one fixed. So this needs to be in a fixed position. Otherwise we won't be able to make that constraint. If I try to control click both of those and create that sphere constraint, it's going to complain about one not being fixed. Okay, that, and delete it and hit yes. So let's convert these to A2Plus parts. So we'll click on part, and we can use the convert a part to A2Plus from the toolbar, or we can click on one of the parts and come up to A2Plus and convert a part to A2Plus part. Now they're converted, we'll take one sphere, control click the other. I haven't set this as a fixed position yet. We'll just constrain that, OK the constraint, and accept. And what we'll do is then click on this one, come down to fixed position. So taking the one that we want to make fixed, where it's got false, let's set this to true, and click off and come over to solve the constraint. So the Rubik's Cube here, or A2Plus, solve constraint. We've now constrained that sphere inside this box via the sphere within here. I can't move this. If I click on the move selected part under constraint, remember this is a move from last video. If I try and move this, you can see it's slightly moving in there, but it's not doing anything. And the reason is, if I transform this, right click, transform, this is what this move tool is doing. We need another constraint in here because this needs to rotate inside here for the constraint to work. At the moment, this is locked in here. We haven't got any dynamic movement in there. I'm going to come over to the cylinder in the part and just add a cylinder in here. And this takes us nicely back over on the A2Plus workbench to the circle and circle, the other constraint I want to talk about. Convert the cylinder to a A2Plus part. That means we've got all the properties that we need for change this as an A2Plus part. Now I've got the cylinder in there. Let's take the bottom circle and control click the top circle of that cut, so that sphere that we've placed in there, and use the circle and circle constraint. That makes a coincident constraint with that circle. We've got some offset as well if we need it. Also, we've got the flip direction, so we can send it in different directions. Now what's happened is that we have this circle constrained in line with this circle. It can't move away from that circle. It can rotate in place. The thing is now, if I move this using the move the selected part under constraint, we can move this left, right, back and forth, etc. At the moment, because I've got it from the right view, we can see we're just moving it left and right there. If you look how I move it, if I move the mouse pointer this way, you see how that's moving. And it will stop at a certain position. That's because I need to start moving it down. So if we start moving it down this way, you can see this is moving this part, and the part underneath it, this sphere, is rotating. So we're dealing with transformation, not rotation. And this is the reason why this can move. If I move that with the plain move tool, move this over, okay that, and hit Rubik's Cube, it will just snap back, the same as this one. We tried to move the sphere out, hit OK, and use the Rubik's Cube to solve the constraint, it will just go back in. So we created a very simple ball joint here. Remember that the solver doesn't allow for collision detection, so just be wary of that. It's a dynamic assembly, but we haven't got that kind of collision detection in there to stop it from passing out of this circle. There's certain things we can do to simulate it up to an extent, but that requires additional constraints, and the more constraints we have, obviously the more processor power intensive it is. But this is enough for a basic ball joint. So that's the sphere in sphere constraint. Now the circle and circle constraint, which we've added here, allows me to control this sphere because this circle won't move outside of this circle. It's fixed to it. The thing that will happen, it will allow for rotation as well. So I'm going to break the constraint of this cut. So this one here, I'm going to set this to fixed position of false. I'm going to come into this cut, and we've got the sphere coincident constraint. Let's delete that, and we'll delete the circle edge constraint as well. Let's get rid of that as well. So we've got no constraints in here, and I'm just going to delete that cube, get rid of that cube. So at the moment, if I move selected part under constraint, we will separate these, hit the solve, and nothing happens because we haven't got any constraints. I'm going to fix the position of this sphere now. Fix position as true. And we'll use the circle and circle constraint here to here. And circle and circle. Set that. So these circles are now attached. If I try to move this, then it won't move because we're trying to transform the cylinder on a fixed position. I'm going to take that same cylinder and make a duplicate of it using the duplicate tool or A2Plus create a duplicate part. What that allows me to do is, what we'll do is click on that and just move that out of the way. Let's move it over here. It was actually still attached to my mouse pointer, so that's okay. And we'll use the bottom circle here, control click the top circle, use the circle and circle constraint, and accept that. So we've got two cylinders on top of each other. If I try to move this now with move selected part under constraint, then you can see we've got very slight movement in there, but it's not going to move because, again, we're trying to transform this. This is fixed. This is constrained against the circle, so it won't move outside this circle. So transformation is not allowed. If I bring this around, we can see that we have these two lines aligned at the moment. But if I click on this cylinder, right click, transform, and I'm going to rotate this. I'm going to rotate it this way. You can see the line here is not in line. Okay, that. And hit the solve. Nothing's happened. So this has an allowance for movement around. So this will actually spin on here. And we can prove that by coming over to the part workbench. And actually I'm going to come into the sketcher. And I'm going to create a sketch along the XY plane, which is fine. Let's hide the cylinders. So let's hide this one, and this one, and create a slot. And hit task. We've got some redundant constraints, so let's just delete that. And we'll create a circle in here as well. So we've got that there. Let's come over to the part and extrude that. So basically this is going to be a handle. And let's extrude this by 2mm. Got the circle to do the constraints against. Let's come over to A2Plus and convert that to an A2Plus part by clicking on the extrude and using the convert to A2Plus part or A2Plus convert part. So that's an A2Plus part now. Let's bring back the other cylinder and this one, and also we want the cut, so we've got those there. At the moment this isn't constrained, so what I'm going to do is take the circle, control click the cylinder circle, so those are selected, you see those in green, and use the circle and circle constraint. So it's been moved up. We've got this offset here as well to allow us to move it in different positions as well. Let's just accept that. Now we can move this. I'm going to use the move tool. I'm not using the move selected part under constraint. If I click on that, you see we can't transform it. There's a bit of movement in there, but it's not enough to actually warrant any dynamics. Let's click on this and use the plane move tool and rotate this. So it's going to be the blue, and we'll rotate this around to here and hit OK. Let's hit the solve. You can see that's rotated around, but none of this has rotated. So that's rotate this one here as well. Rotate this around. You can see nothing's really happening. If I wanted to keep these together, I need a different kind of constraint. As well as the circle constraint that allows me to rotate around that circle, we need to find some other kind of constraint. So what happens if we take, say, these two lines? So this one here and this one here. Control selected both of those. We've got a number of constraints that have appeared. And we've got this add axis coincident constraint. That keeps the axis of those two lines, you think of the axis runs through here, in line. So we add that one. Those are kept in line now. So we've got the circle constraint against these. But if I click one of these and use a rotate this around to here, OK, we can see the lines aren't aligned now. The axes of those lines aren't aligned. Hit the solve, you'll see it'll flip back round. Same with this one. Okay, that. Use the solve, and you'll see that's moved around. So how do we get this constrained? So if we change, say, the rotation of this shaft, this moves as well. Well, if we look at the hole, we've got a line within here. So if we change the diameter of this hole and close it up, so it's the same diameter as the shaft itself, and if we go in the cylinder, and it's a basic cylinder, so that's what, so it's 2 millimeters, so it's a 4 millimeter hole. Coming to this extrude, which is this one, the original extrude, double click that sketch, and that's set the diameter of this hole. And what I need to do is just hide this extrude so I can see what I'm doing. So we've got that circle there. Let's set the diameter of that. At the moment it's 6.77, that's set to 4. So let's tighten that up against there. That means if I close that, bring back the extrude, we can see nothing's taken effect yet. Let's refresh. It says, do you want to update only the selected parts? Go yes. So the one that I've selected, it will only update that part. And we see we've closed that hole. I'm going to move this now. Just move it up the way, up and out, so I can see inside. And okay. I can now take this line, and if we look inside, because it's a cylinder, there will be an edge. Control click this line and use the axis coincident constraint and accept that. So now we've got that constraint in there. Everything's inlined. That means when I rotate this one, rotate this around, the axis is off for this. Let's hit OK and hit solve. You can see it flips back. Let's rotate this shaft. Let's get those all in line. So if we rotate this shaft now, like so, okay. So we can see that's out of line. Now when we hit the solve, this one flips around. And we can control other objects with those. So when we have a rotating handle, we can rotate something that pulls something else. Let's try that. So what I've done is create a new document. I'm going to create a very, very simple assembly in here with some moving dynamic parts using the sphere constraint, the circle constraint, and the axis coincident constraint. So we'll create a new sketch, XY plane, and the first one I'm going to do is basically going to be a wheel that we can place on an axle, and it's going to have also a hole here. So we'll rotate around this circle here, which we're going to set to 4 millimeters, and also something's going to be attached to here, so it can drive something else. And we'll set the outer circle as well. Set that to 45, and we'll set this some distance away from here to here, and 15. So we've got that. Let's come over to the part, and we'll just extrude that by 5 millimeters. So we've got our first part, which is the extrude. Let's hide that and create another part. Again, using the sketcher, we can use part design for this, but I'm going to keep it in the part for the time being, XY plane, and I'm going to use a slot, and we'll make that symmetrical to the center here using the symmetry constraint. Make sure this top line is along horizontal, and we'll place 2 circles. Each of these are going to be the same, and each of these are going to be 4 millimeters. So a diameter of 4 millimeters. We've just selected both of them and done that diameter in there. Set some length. Let's set this about 40 millimeters. And we'll do some height as well, just to constrain it down. So let's do diameter on there of 10 millimeters. So we've got that there, let's close that, and that's come over to the part and extrude that by 3 mil. So we've got that one there. So we've got two parts. We've got the first extrude and this wheel. I'm also going to create a cylinder. Now the cylinder needs to be 4 millimeters in diameter. So we've got a radius of 2 millimeters there, which is correct. And this is going to be the axle that the wheel sits on. So it's going to be fixed point. Let's come over to the A2Plus workbench and start construction and assembly. First, let's take the cylinder and transform it somewhere. Now we can use the move apart under constraint, and that will just pick it up and we can place it somewhere like so. To make this fixed, I can't make this fixed at the moment because it's not an A2Plus part. That's an A2Plus operation, so we can convert it to part or part to A2Plus and convert a part to A2Plus part. So we have that cylinder there, and we can see it's up there. It's just moved. So we can position this where we want, and we'll fix that now. So if I click on that cylinder, we can see we've got the fixed position. I set that to true. So we'll always need to constrain against something that's fixed. So this one's been fixed. Let's bring back the other extrude, which is this wheel. Click on the extrude. I'm going to do the same. Convert to an A2Plus part. I'm just going to use the toolbar. And we're going to make our first constraint. So the first constraint we're going to use is to constrain this wheel against the fixed part. And I'm going to use the circle and circle constraint. So I click on the circle, control clicking on that top circle, and we see the circle and circle constraint has appeared. So click that, and that's moved that into position. Got some offset, so I can offset it up or backwards. I'm just going to move it backwards and set that. So at the moment, if we come over to the left hand side, we can see we've got the cylinder. Inside here we've got a circle edge constraint, and inside the extrude we've got the same. So these are matching constraints. So if I try to move this now using the standard move the selected part, which is right click transform, OK, and then use the Rubik's Cube, this will snap back. So places it back in position. Rotation is fine with this, so I click on it and rotate this around. Then that's absolutely fine. I hit OK. Then if I hit resolve, you can see that's just rotated around there. Keep an eye on, say, this line here. That shows that hasn't rotated, but because this hole's here, you can see it's rotated around here. So the disc itself has rotated around. The axle's just kept static. That's fixed position. If I rotate that axle, so the cylinder, right click transform, rotate this around, say to here, and hit OK. The reason why it's rotated like this is because I transformed it before I created an A2Plus part, so the axes are off. So I resolve that now. You can see this has moved over to where it is. If I just come in to the part and created a cylinder here and then selected the cylinder over into A2Plus and converted it to an A2Plus part, then if I right click transform, you can see our center of rotation is actually where it was originally created from. Whereas this one, right click transform, you can see, well, it's off because I moved it before I created that as an A2Plus part. It's not to worry, let's delete that one. We're not going to be doing anything with the axle, it's just going to be staying there. Now I'm going to use the circle and circle constraint with these two. It's taking this circle here, control clicking this circle, and using a circle on circle constraint. That's in there, and we can use some offset to place it on top. Like so, and set that. So now if I move a part under constraint, we'll see that we can move this around, no problems at all. So we're actually moving this part here, and you can see that the movement will move that wheel, and you can see an edge. See that edge of that wheel? It's being rotated around here. So if this is rotating around like so, we could add, say, a ball joint onto this part here. So create a quick ball joint, come over to the part and create, let's go for a cylinder. Click on the cylinder and we're going to set the radius for around 5. So we've got that there. Now we're going to take a sphere away from in here. Let's create a sphere. That's sitting there. Click on the sphere, right click, transform. We're going to set the sphere inside, and also I'm going to set the radius of it. Just going to bring this down to 3, so it's inside there. Do a bit more transformation and make sure it just comes out the top like so. Okay, that. Click on the one that I want to keep, which is the cylinder, and I want to make the sphere remove the material from inside using the cut from the toolbar or part, boolean, and cut. So now I'm going to come over to A2Plus and set this as an A2Plus part. So I've clicked on the cut and use the toolbar, convert a part to A2Plus part. Now you can see from over the left hand side that I've got this rogue circle edge constraint here. And this is the reason why you convert stuff to an A2Plus part before you start adding constraints. If we look down, we've got extrude object extrude 001, which is this one, which I didn't convert to an A2Plus part. So it's actually sat the constraint outside. It doesn't matter, but if it's inside, we can see exactly what's constrained against there. I'm just going to leave that for the time being. We're going to line these circles. So I'm going to take this circle and control click this circle. Now we've got a number of options. We can align it by the circle, which will allow that to rotate, or we can align by axis coincident constraint. If I use axis coincident constraint, it'll push it away from there, which I don't want. So I'm just going to delete that and hit yes. We want it circle and circle. So this circle and this circle and circle constraint, and set that. So that's on there. If we want to, we can take this line and control click this one and use the axis coincident constraint. So the two axes of those lines, because the diameter of those two are the same, that keeps those in lines. So this won't twist anymore. That's in there. So now we've got that. We can create something here. Now the idea that I'm thinking of is that if we move this under constraint, then we can actually attach or constrain a ball joint and then have the other end attached to something else. So let's do that. Let's create the actual ball joint. For that, I'm going to come back over to the part and create a circle. So this circle is going to sit inside this one. This will still sit inside here no matter what size it is, because remember, we're not constraining size, it's just that object on or in another object. We've got no concept of the boundaries of that in the dynamics of this program. So I'll take that sphere and control click this sphere inside here, and let's come over to the A2Plus and use the sphere on sphere constraint. Then that's valid. It's embedded in there, but it's valid. Let's just delete that. Hit yes. And what I'm going to do is just convert this to an A2Plus part. First of all, let's move it out of the way. And I'm going to move it back to the origin. So position 0, and just 0 those out. There we go. And we'll convert that to an A2+ part, or A2+ convert to A2+ part. So we've got that sphere now. So the sphere inside this cut here was taken from this object. And we can click on that sphere and we can see the sphere itself was a radius of 3 millimeters. So let's do the same for this one. We've got to edit the original one because at the moment, because this is an A2+ part, then we have all the A2+ options which don't include the radius. We have to go back to the original sphere. Hide the placement and come down to the radius and set that to 3. It's not going to take. What we need to do is click that sphere and use the refresh or A2+ update parts imported into the assembly. I've only selected on one, then it's going to give me the option to update just that one or the whole lot. I just want to update that one. Let's hit yes. This will be now the right size. But I want to update this to have a stem coming out the top. So I'm going to get rid of that original sphere. Let's delete that and bring back the part. Come over to the part, and that's first. Well, I could remove something from here, or I could create this as 2 parts of the assembly, so a sphere with the top cut off and then a cylinder on top. All I'm going to do is add a cylinder, and we'll take that cylinder and set some radius of 2. Let's set this to 1, and we'll set some height as well. I may change this, so I've got it at 30 at the moment, like so. That's boolean these together, so let's take the sphere and the cylinder, part, boolean, union those together. Now I'm going to take that fusion over into the A2+ workbench and convert that to an A2+ part. Convert to an A2+ part. Make a constraint against the sphere and this internal sphere, sphere on sphere constraint, and set that. That's sitting inside that, and what we'll do is just rotate this around the right way. To do that, come to the fusion, right click, transform, and we'll rotate this around. So it's around this way. Hit OK. So we've got that there. If I simulate this with the move apart under constraint, we can see that's moving fine, but you can see we've got animation problem detected, and that's because I tried to move that at an odd angle. So I'm going to come around and just move it from this angle. We're getting multiple parts under constraint now, so we just have to be a bit careful and a bit gentle with the animation. So we can see that's moving fine. If I pull this right over here and try to get this at an odd angle, and now it's not going to do it, sometimes it would rip this apart because we're trying to pull it against the constraint. I'm going to lengthen this cylinder a bit. So come into the fusion. Well, we need the original fusion, this one here. Click on this cylinder and set this to 50. Hit enter. Click on the fusion, so this one here, and hit refresh. So it only updates the selected part. Let's hit yes. Cylinder is now lengthened. And I'm going to use this cut and duplicate that using the duplicate. And it's attached to the mouse pointer. And also I'm going to do the same with this one here. So this fusion here, we're going to duplicate that as well. So we've got 2. I would add the ball to the other end here, but we're just going to do this quickly. Now I'm going to take a circle on circle constraint between these 2. Circle and circle. We need to flip the direction. So we've got that one there, set that. And then we can take this sphere and this sphere, control click those, and use a sphere on sphere constraint. set that, and that's round the wrong way, so let's click on this one and rotate it using the transform, and we'll rotate this around, and when the solve is done it will just pop back into position. So okay that, and solve. So we've got that there. Now let's come around to the front and just straighten this up a bit and move this around. Okay that, and hit the solve. So that's positioned properly now. So now if I click on the ball joint and go over to the properties and set the fixed position as true, then that can't move. And we should be able to simulate the whole assembly together as one. So we're going to start simulating the model now. Now, word of warning, we have to be mindful of the actual limits of each of these pieces. For instance, if I push this right over this way, this is fixed. So in a real life assembly, that will actually either fail or be ripped apart. And the same is with the dynamic assembly. So if I go to move apart under constraint and select the wheel and start moving this, we have to go carefully, otherwise we'll end up pulling this apart. So I've gone beyond the limits of the constraint and things have started to fail. If I hit Control Z, I'm back to where I was. I find the best idea is to zoom in and then start moving some of the assembly, but just a little bit so we get an idea of the limits of the actual constraint. So I'm just moving around this wheel and I can see how the ball joints are moving. If I go too far, and sometimes it won't happen, but if I make a sudden movement, so you can see this is going too far, this is starting to fail, and it starts to fall apart. Using Control Z or using the solve tool, we'll resolve that constraint and put it back into place. Obviously we can move different parts, so I'm just going to move this part. And you can see we've got control over that part, and I've moved that part too far. So this just gives you an idea of the movement and the constraints that you have and how they are working together. So you can see those ball joints are working as we move this around this flywheel. Going forward, we have the other constraints up here. So we've got axis parallel, axis plane parallel, etc., all along here. And we got a number of other constraints for other types of assemblies. But this gives you an idea from the last two videos how these constraints are put together and how they can be used together to create a full assembly. In the future we'll be going over these as well and doing assemblies with those just to show you how those work. Hope you enjoyed this video and I hope to see you again soon.
If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.